Welcome to another episode of the Virtual Reality Reconstructionist. I'm your host, Roger Ryan Ryder, owner of Triple R Investigations. Today, we're discussing reconstruction software with Matthias Schmidt, CEO of Analyzer Pro. Matthias is a leader in a field of software for traffic analysis and has embarked on a journey with Analyzer Pro as a solution for industry professionals. Analyzer Pro is a software that expands an entire spectrum of crash analysis. Software brings a focus to area of distance, time, relationships, also known as kinematics, and the emerging significance of data analysis. Matthias took over Analyzer Pro 2016 while studying in Vienna University of Technology. His focus was to bring Analyzer Pro to the forefront of accident analysis experts around the globe. Analyzer Pro is being used in over 25 countries today. In addition to starting a focus on growing Analyzer Pro, Matthias is growing his family. Let's get into the interview. Welcome, Matthias. How are you doing today?
I'm doing fine. Thanks so much for having me.
Yeah, you've got some great things going on. I think we'll just start off with, why don't you tell us a story about Analyzer Pro and becoming the company's CEO?
Yeah, so when I finished high school, I wanted to study physics. And I come from a little town in Austria called Salzburg. That's the place where Mozart comes from, by the way. And I wanted to talk to someone who had studied physics. And the only person I could come up with was a guy in his 60s that I knew over a common friend. We scheduled like a coffee, we met. He told me 5 minutes about studying physics and then like 1 hour about his super boring software for traffic accident analysis. And I was really not impressed. But then I started studying physics but we kept in loose contact. And through our common friend, I got more and more like the information that the guy wanted to retire. So at some point I thought like, let's give it a try. And I wrote him an email and asked essentially, can I buy your company? And he said, sure. And I got my best friend and we had back then no idea how to code. We had no idea about traffic accident analysis, and we had definitely no idea how to run a company. But we were 23 years old and thought like, how hard could it possibly be? And turns out if you just invest a lot of time into things, they work out. And yeah, that's how we founded like the company that exists now, which is now almost 8 years ago. And we took over the source code, and some already existing customers continued to develop. In the beginning, people were kind of like, oh, okay, this guy wants to retire, so I'm not sure if I should stay on that boat or not. And then we had to, in the beginning, convince our existing customers that we are serious because, let's be honest, nobody trusts two 23-year-olds that easily. Well, so we did that. We reworked a lot of old code over the years. And then we started to gradually expand, first to other European countries and then now even outside Europe more and more. And that's how it happened.
But I think it's kind of different when it's yours that you own and working those extra time and effort. You have the vision, right? You know where it's going, and you got to drive that bus to that location. So.
Yeah. Motivation is definitely completely different. Yeah, if you do it for yourself. And we wanted to make it happen. It was like we started it, so failing wasn't an option. Yeah, thank you so much.
Yeah. So if we get into the software, what do you think the top features of Analyzer Pro are that makes it the global leader in the crash analysis software business?
Yeah. So in order to answer that question, I probably want to do a little bit, a small jump back in the history of Analyzer. As I told you, I bought the original source code from a guy who was a court expert in Austria, and he mainly developed it for himself for the first, 20 years almost. So it started like as an old DOS program, with the the green numbers on the black screen. And he continued developing that. And then if somebody wanted to buy it, it was okay. And if not, it was also okay. So it wasn't a commercial product for a long time. So he developed Analyzer in a way that it perfectly fulfilled his needs. And his needs were to be quite fast in his work. And what we sometimes do in Austria is we sometimes have to even calculate live at court. So if there's new evidence coming in, the expert has to be in the position to just like double check the evidence on the spot. And that made it necessary to create an environment or a software where you could simply do that. And long story short, this is why the core of Analyzer is definitely to be seen in kinematics. Because in kinematics, you can do so many things so easily because you have an understanding about certain movement procedures. And kinematics allows you to put that into formulas super easily, visualize it, put it out there, get the results, and that's it. So if I ask our customers that work with Analyzer for many, many years, they would probably say kinematics is probably our most outstanding feature or a set of features that we work with. But of course, on the other hand, we also have in our more recent developments put a heavy focus on all types of data analysis, since I believe that the work of the traffic accident expert is already and will be even more shifting in that direction. We get more and more data. Of course, we have these like big topics like Bosch CDR, where we spent a lot of effort into making a seamless integration of the data, visualization of that data, but also simpler things like sports watches and that kind of stuff. And another topic that I would also put under the umbrella of data analysis is definitely video analysis. That seems to be quite popular in the industry. So, for example, we have created a tool where you can put in camera footage from, for example, CCTV, and using AI to determine speeds of the moving cars or cyclists or pedestrians or motorbikes or whatever. And that works quite well and is also super interesting for us from a developer's point of view, of course. Yeah, what else? I'd say the whole 3D integration is something that is quite useful and works quite smoothly. We have, since a few years, like laser scanners became more popular, 3D photogrammetry became more popular, and we have found solutions for all these different sources of data just to put them in quite easily into Analyzer. And that just creates a much more presentable environment, especially if you think about the courtroom. And if you can let the car not just go in some randomly drawn environment, but in the actual environment that just looks, first of all, cool, and second, quite convincing and real. Last but not least, we have a pretty cool feature called automatic collision analysis that I originally wrote as a part of my master's thesis in university. It's, of course, way further developed by now. But that's a tool that allows you to do this complicated part of a forward simulation, like if you have collision and run out automatically by a computer. And it does that quite fast and quite accurately. And that's also something we're proud of, I would say.
Yeah. No, it's I think that's part of it. Is what we see in the U.S. is how do we transfer that information into a jury that appears that don't have any idea what we're talking about, and how do we make it simple, and how do we make it make sense. And like you said, physics can get quite mind-boggling and confusing, and you talk to somebody and you get them into that state and they just want to shut down. So your collision analysis is definitely a plus because they get to see a visual, right? We get to not just tell them, but show them. So we get more aspects to help them understand that. A very, very good point. Now, I like your interest in expanding, even though sport watches aren't part of it. But, you're seeing investigators use that, right? They're starting to use different concepts. And if you put it into one spot for an analysis, it helps keep you focused, not have to jump around to different components, different things to resolve, or at least, have a visual, like you said, a little table or something that helps somebody understand how they correlate and work together. So, yeah, and I think, you're speaking about the 3D aspect. That's obviously where we're coming from for the podcast, and I'm trying to help people understand, but that's just another visual aspect, right? Is if, as experts, we tend to understand that, but that's what we're there for. But how do we visualize that to anybody else that we're trying to explain this to? And your integration in that is very helpful. I think part of it was that I'm seeing with 3D stuff is just the amount of damage to a car, right? As the physical aspect. Pictures just don't do it justice when we can see it in 3D and see the amount of damage into the car. That makes sense of why it can harm somebody, and that makes sense of a high speed damages a car quite extensively. So, yeah.
And also, like, an aspect I really like about that is what you can quite easily do is you can nowadays go out there to a repair shop, scan car number 1, then go to the other repair shop, scan car number 2, and then you can just digitally put them together, say, okay, do these damages actually fit? In which angle do they fit? And so on. And that's super valuable clues for your reconstruction. So cool stuff going on.
Great, interesting stuff. All right. So the next aspect I think we're looking at was the audience, with physics and kinematics is going to be a little bit confusing. So if you would explain in short terms, kinematics, what does it mean and how is it important to this crash analysis and your software?
Yeah, happy to. Kinematics is, if we put the headline there, is in a nutshell just the movement of points, which sounds very theoretical on the first glimpse, but it is quite relatable if we're just saying a car is going with 30 miles per hour. That's kinematics. We can say, okay, car is going with 30 miles per hour for, 20 meters. And then we can immediately calculate the distance out of that. That's kinematics. We only need 4 variables, which is speed, time, distance, and acceleration or deceleration, which is mathematically the same thing. And the good thing about these variables is there is tons of research about it. We know what a typical deceleration on a dry ground with like heavy braking is. We have good understanding about what is a typical reaction time. And it's also so relatable for people in the courtroom. It is easy to estimate, and we can do a lot of things. And speaking from a reconstructionist's approach, you could theoretically calculate also everything with a dynamic simulation. It's just much, much, much more effort. And there is no additional value in that as long as we are speaking about orderly driving behavior. If you're talking about a collision, the moment of the collision itself, or some skidding, then we can't use kinematics anymore. But for every type of orderly driving behavior where the car is moving as it's supposed to move, we can use kinematics. And that makes, also things like avoidance calculations doable. For example, in Analyze with just one click, you can know, okay, but would this accident have happened also if he went with that or that speed? Or at which speed? Or would he just have needed a higher deceleration to avoid it or to react earlier? And all these questions can be just super easily solved with kinematics, with relatable and feelable data. That's how I would describe it.
Okay. Yeah, well, it's quite interesting. We evolved in this concept of, physics into kinematics, but I think it's probably that we understand it better, that we can simplify it and make it reasonable for those to understand, even though we know in depth what is happening. We're just kind of making it more realistic, right? Because a lot of the car crash stuff that we see about, we have a lot of energy, a lot of damage, but, it's still relative, right? It's still as far as the amount of damage versus speed and versus, what you can get, is 1 or 2 miles an hour, really a big difference. Not really, right? Because we're usually talking about excessive speed, high speeds, double the speed limits and that kind of stuff. I know in the U.S. that's what we're dealing with a lot with fatalities.
Mm.
And that excessive speeds are, quite obvious. And you explain it to them to understand that. So I think y'all are probably doing a little bit more investigative studies on minor stuff. And I think in the U.S., unless that gets into a civil court for some reason, none of that's done on a daily basis unless they pursue that. So, interesting concept as far as having that available out in the field.
Yeah.
So, great discussion on kinematics. And on your website, it's talking about kinetics and driving dynamics you mentioned on the website for Analyzer Pro. Kind of give us a understanding of the mention of that and what you're doing with those two.
Yeah. So as I mentioned, kinematics is great, but it is not applicable for every situation at every given time. We have situations like a collision or some skidding or run out behavior where kinematics is just not sufficient to physically calculate and describe the movement of, let's say, a car. So then we need a dynamic simulation. And the concept of a dynamic simulation is that you try to bring in a model that resembles nature as close as possible. As close as possible, because an exact copy of nature is unfortunately not possible. But you try to do that. And then you're dealing with tons of parameters like stiffnesses and friction values and so on and so on and so on. But that allows us to calculate complex scenarios. Don't know. Car is crashing against another car and is skidding around and rotating and rolling over and so on. And with that, we can still deal with these scenarios. So how you would typically work in Analyzer is and let's say you have a car crash, you would first start with the collision analysis and the runout analysis to find your final positions and therefore retrieve the collision speeds. And then from there, from the collision speeds, backwards in time, you would go and continue with kinematics and calculate the approach of the car. And then you could do things on top like avoidance calculations and so on. Yeah. And of course, we do also have these parts inside Analyzer, like the whole collision analysis, driving dynamics. It's a must-have. No doubt about that.
I think so. I think the further and further I get into car crashes, we understand that the human interaction is a big part of it, right? How do they react, and are they panicking? Are they turning while they're doing this? Was it a delayed response on some alert to put the brakes on? So a lot of things going on there with the human side, and it's good that y'all are making sure that that's part of the formula to get an end result, because it is quite a bit of it. Even though we may have a window potentials, it still is that. That's what you were referring to on the dynamics of the human interaction. Sometimes it's quite broad.
Totally, but I think it is almost the duty of the expert to deal with windows rather than like it is 30.356 miles per hour, because traffic accident analysis is not an exact or super duper precise science. Everything is based on assumption. The best simulation we can possibly do is based on assumptions. And therefore, we have to always work with ranges of results. But that's good enough. If we can say, okay, this car was going with 30 to 35 miles per hour, that is good enough. And I think it's the correct way to work if you put it out like that. And sometimes that may include the fact that you have to say, okay, I can only give you a wider range of results. But I think, personally, that's still better than just making up numbers and pretending that there is a precision going on that is actually not going on. And I know from experience, it's like some, I don't know, judges or lawyers or whatever want you to say something, oh, it is exactly that and that. And then you gotta have the guts to stand up to that and saying, no, sorry, it's a range. It is what it is.
Yeah, I think it's a lot of, so in the U.S., the struggle to get that human, so not just the human factor, but like faults when a person's hit and slides and that kind of stuff. get that into court because there's so many dynamics where they hit, what was the body positioning, leg positioning, arms, and there's just a lot of assumptions when you start dealing with that. With cars, they're metal, so you can, make some assumptions or know what damage has occurred where. So, yeah, it's a great point, and it's still a struggle to get those in today. Even with a video, you think about today, you have a video of an incident, to recreate that and get it right, and body dynamics is just, you're still, unless you have a 360 evolution of around the body to know what everything's doing, it's still a struggle to reproduce that, right?
Absolutely.
Like you said, assumptions are a big part of it. But luckily, the assumptions, they've been documenting them and saving them, so we have resources to make them consistent, right?
Yeah, absolutely.
Yeah. So other than your software, I know you're dealing with reconstructionists, but I understand you're also dealing with some police departments with various interests in the software. Can you tell us about any interaction with the police forces? What are they asking for with Analyzer Pro?
Yeah. So we have several police forces from different countries working with Analyzer for many years, and it's so different where they all are. Like some of them are like top-notch educated people with like super fancy equipment, and they're just like the perfect reconstructionists, I could almost say. Others are performing like rather simpler tasks, like doing a sketch and doing some basic kinematic analysis. But throughout Europe and with increasing popularity, we get more and more police forces. I can't really tell names because it's a bit kind of a sensitive topic, but several European countries use Analyzer in the police departments. Usually they have like small specialized departments within their state police, and then they get all the cases in and then work them through. But there is more and more happening in that area, which makes me happy, of course.
Yeah, and I think we've all been through that. What I saw in law enforcement was a change in that expertise, right? Not just an investigator filing a case. They really had to know how they came up with the speeds and what evidence was there. And evidence on the scene, can get lost or misinterpreted. And the expert or the engineer who wasn't involved, usually was involved later, but now the officers involved more and more because they are true reconstructionists with the training and knowledge and everything. And being on the scene is quite different.
Yeah.
And like for me, now that I do consulting work after the fact, it's a totally different approach on reconstruction incident as it was when I was on the scene and been there and documented it and then worked it. So, that
totally.
actual interaction is quite interesting, and having access to software like Analyzer Pro to help you move along and prove some things is very helpful.
I don't even want to blame the police forces because very often I have the feeling that they just don't get the proper information or education what to do, because it wouldn't make a difference for the officer in the field to make a photo from that angle rather than that angle. But how would they know if nobody ever told them? So I actually appreciate that there is at least a slight push in Europe going on to educate police officers in that field a little bit more, because it can make such a difference. If you can, don't know, get the final resting positions of the cars, it's just a huge difference in my later reconstruction job than if I just not have them, or if I just have some, don't know, close pictures where I can roughly estimate, oh, they're standing there, or maybe they are not, I don't know. So I see it positive. There is a little bit of movement going on, and so far all the police forces I've worked with have been quite nice and competent people. So good thing.
Yeah, good. Yeah, I think that's just part of learning the system and trying to adapt to it and doing the best we can, right, as far as that's concerned. And it evolved with me. It was down to, we started out with total stations and, went into 3D scanning and, learned more and more about, auto pedestrian, motorcycle crashes. So it was the same kind of thing we're seeing, I think, everywhere. And it's sometimes just different places. I think that was driven here through the court system in the U.S. So the virtual reality reconstructions is always interested in the 3D scanning and the virtual reality, but we also review the need for crash and crime scene reconstruction. So tell us how your 3D animation has developed with Analyzer Pro.
Yeah, so we really jumped on that train when a few years back a software called Argisoft Metashape came on the market, or at least I learned about it, which is one of probably nowadays many softwares that take photos, regular photos, and create a 3D environment out of them, either in form of a point cloud or of a mesh. And we started to integrate that because we found out that the process of creating landscapes or accident sites is super easy if you once you get a hang of the process. Then obviously there was the big topic of laser scanners, which are not so popular in Central Europe, because courts don't financially make a difference if you make a 3D photogrammetry or a laser scan, and the laser scan, the scanner costs you, I don't know, $60,000 or something around that. So people naturally pivoted towards the 3D photogrammetry. However, if you look, for example, at the UK or America, people do use laser scanners quite often. And there are great companies out there, like I know the guys from, for example, or there are others, and they create point clouds, which initially was a problem for us because we were used from 3D photogrammetry that we would get meshes. But what we did then is we developed an algorithm to automatically create meshes out of point clouds, which is great because then you can just have seamless integration. You just take your point cloud, drag it into Analyzer, and boom, there it is. And the cool thing is that then the surface is understood by the program as a surface. So if it goes up and we do a dynamic simulation, the car will go slower, and if it goes down, it will go faster. But all of these things are super nice when it comes to recording accident sites, but especially the 3D photogrammetry always had a problem with recording cars. Everything that has reflective or transparent surfaces just didn't work out well. It always looked like someone poured acid on the car, so not really usable, right? So I was quite happy when I learned about this other software going on called Recon 3D, which is, I don't know, on the market for a year or a bit more than a year. And they use the LiDAR from the iPhone to create models, and that works excellent with cars. And we reached out and got in contact with Eugene, the founder, and made it happen that their data also works in Analyzer, the exact same way the other types of data work. And with that, I think we've closed the last gap that you can now scan, record, and integrate it quite smoothly into Analyzer. And you could theoretically now, scan the scene, put it in Analyzer, then go to the repair shop, scan the two cars, put them on the scene, and then have them perfectly there. And besides looking cool, it's also quite useful for the further process, I think.
Yeah, that's nice, because once again, it's a visual aspect that we can do it, and especially like you're talking about Recon 3D, the time frame, right, to get this data is very reasonable. With photography, you're talking hundreds of pictures.
Yeah.
It's a great end product. It is time consuming, so using that LiDAR on the phone is going to be a big help in doing that. Now, in Analyzer Pro, can you do a 3D background like from Google or anything to, instead of just a block, you can kind of show the area that it was in?
Yeah. I mean, that was something we always used to do, especially before that whole scanning stuff came in. So you have a module where you can just use Google Maps, Google Earth, and these things, and just search for your place, click on it, and then you have it there. That's super simple and straightforward. Or you can just take, if you have a drone and you want to put in the drone photo, you can just drag and drop it in. So if you ever want to not want to make the effort to do a scan, then that's your way to go. It's just easy. Takes 20 seconds.
Yeah. Well, you also have a bank of models to represent a lot of cars too. If somebody doesn't have a scanner, right, they can at least get a representation of a car.
Yeah.
Close to what they're dealing with.
Yeah, and they're quite accurate, actually. We, when 3D became more and more important for us, we had to make a decision what to do with the cars. Because if you now like go to Google and search for, I don't know, 3D car model, you will get any 3D model for, I don't know, $2. But the quality of that model is most likely underwhelming, and also most likely underwhelming from a technical perspective, because only if someone can make a nice screenshot of a car doesn't mean that is like designed properly. And we thought like, oh my god, if I now like open Analyzer up for all these imports, my phone will go crazy with people saying, oh, I bought this $2 model and now it's looking weird. So I felt like, nah, let's not do that and make our own 3D models, which we started a few years back, and we continuously growing our database. But also we have an on-demand service where you can get any model you want within 3 days. It costs a little bit, but it's like not crazy. And our models are quite accurate. Like you can use them for damage height comparison and so on. And we found that is a good way to ensure quality in that field.
Yeah, well, that's a good feature to have as far as in the 3D arena for software. So, Matthias, in closing, would you like to add anything about? I know you're doing seminars on various, not just Analyzer Pro, but some 3D concepts supported by you.
Yeah, I got recently asked if I can do another course for 3D photogrammetry with Agisoft, which is going to happen, I think, on the 16th of March, or something like that, which is super simple. But yeah, because I'm still a great fan of 3D photogrammetry. So that's going to happen quite soon. And it's just 2 evenings with 2 hours, or like evenings for me, morning for you probably, 2 hours where everybody who joins afterwards will be able, with his regular equipment and almost no financial investment, to create very nice 3D landscapes. And as I said, we're using that for many years, so I think I have quite a bit of experience going on in that direction. And the other thing is, we of course regularly do like beginner and advanced courses for Analyzer. Especially the beginner courses, they are almost for free, and they're usually stretching out over 4 weeks, so you can try out Analyzer for 4 weeks fully and get some additional like teaching going on. Yeah, so there is I think a course coming up in April in that direction. But generally, I would say we're quite easygoing. So if someone reaches out and says, "Hey, I want to try out Analyzer, or can I do this or that?" we are usually quite open to either give trial licenses or have meetings and discuss a case. So that shouldn't be a problem. And that's always possible, of course.
Yeah, well, excellent. That's great to support the product. I know there's still equipment and software out there that once you purchase it, there's not much after. So I commend you for that. That's what people are looking for. Not that they want you to walk them through every step, but they kind of want to deal with their arena and get a better idea about it.
Yeah,
and get that interaction with you is probably helpful as well. So.
Yeah.
Well, good stuff. Even 3D photogrammetry is still, I think it's going to be there a while. With a camera to create a 3D point cloud, that's reasonable. It's a piece of equipment that everybody has already most of the time. So if you can get the software, you can get into the 3D aspect of whatever you're doing. It doesn't have to be crash reconstruction, but like we're seeing, it's a bigger part of it. So. And meaning, some kind of 3D diagram or some representation of crash and crime scenes, I say in the U.S. and maybe even Europe. I think we're seeing the beginnings of it being a mandatory thing. So you go into a case or, criminal court for sure, that they're going to be expecting this, to be a part of it.
Yeah.
So people can understand the scene and walk through it. And my big hope is, jurors can, walk through it in virtual reality.
I mean,
and
we're not
actually
so
see the scene.
we're not so far from that.
Yeah.
I mean, you could theoretically do that with Analyzer right now. You just you could.
I know there's one civil court that took it, but I think in Europe there a couple of times they've accepted, some kind of virtual reality thing. But we can recreate that better and let a jury, we can take out all the bad stuff. They don't have to relive it live, but they can at least see what it was really like, what positions people were in, and what they saw, and how quick things happened, that kind of stuff.
Yeah, absolutely. Like, especially these whole questions around lines of sight, visibility, perception. That's just great stuff for that.
Yeah, really, really good, especially in court. Well, that wraps up another episode of the Virtual Reality Reconstructionist. We definitely thank you, Matthias Schmidt, for joining us today and sharing his invaluable insight into our world of crash scene investigations. To our listeners, thank you for tuning in. Remember to follow us on the favorite podcast platform for more episodes exploring the fascinating world of virtual reality and forensics investigations. Until next time, this is Roger Reinreiter signing off. Triple R Investigations. Stay safe and stay curious.